A quadratic equation is like a drama with three actors: the square term, the linear term, and the constant. They're all on stage, working together to create perfect balance, that is, to make the equation equal zero. Solving the equation means finding all the real values of x that keep the balance. In other words, you're figuring out what x should be so that the whole scene stays stable. And when everything checks out, the curtain falls, the equation is satisfied, and the audience gives a standing ovation, or at least your teacher gives full marks. Imagine you have a series of switches that transfers electricity from point A to point B. Each switch must be on for the current to flow. Now think of an equation like A times B times C is equal 0. If the electricity doesn't reach the end, that is, if the whole product is 0, it means at least one switch is off. That's the zero factor property. If the product is 0, then at least one factor must be 0. Algebra doesn't care which one. It just knows something killed the current. So when you're solving by factoring, you're basically finding the switches and asking yourself, what value of x will turn this one off? Those are the values which broke the circuit. Just be careful not to electrocute yourself, as this is high-voltage mathematics. Before we can factor and solve, we have to bring everything to one side of the equation, like shutting off the power for diagnosis. If electricity is flowing on both sides, you can't safely trace the issue. Once the circuit is isolated, that is, everything on one side, 0 on the other, we can safely open the box, factor it, and identify what shuts the current down. And remember, no electrician ever fixed a short by leaving wires live. Same goes for math. Shut it down before you break it down. Pull out that GCF like a math wizard. It makes everything simpler and keeps the demons at bay. When that leading coefficient isn't 1, it's a setup for a factoring workout. Do not panic. It's just a clever mathematical matchmaking. The key is finding two numbers that multiply to A times C and add up to B. You're trying to find the perfect couple that clicks just right. Not every pair works, some work partially, but you need the perfect match. When you find the right one, the whole equation factorizes beautifully. True algebraic chemistry. Swipe left on bad pairs, or you'll end up factoring alone at midnight wondering where it all went wrong. This is where factoring meets geometry. We use the Pythagorean theorem to set up an equation, simplify, and solve by factoring, just like we've practiced. But there's one extra step here: interpreting the solution in context. Not all roots make sense in real-world problems, like getting a negative length. That's where mathematical judgment comes in. And when you reject the nonsense answer and choose the one that actually fits the problem, that's when Excellenta Divinatus appears. She is the radiant angel of clean, correct, context-aware algebra. She blesses fully simplified answers and high-scoring word problems, and she loves boxed solutions. You start with a storm of terms, disorganized and defiant. But step by step, rearranging, factoring, and solving, you bring order to the chaos. Each linear factor you extract is a little victory in the grand algebraic battle. This idea was beautifully captured by Sir Isaac Factorton, a legendary knight of mathematics, known for defeating entire armies of trinomials armed only with a chalkboard and an unshakable grasp of the zero-factor property. He once declared, "Taming a chaotic polynomial and breaking it down to its linear factors is a true act of valor." And when you do that in class, especially without a calculator, you carry his legacy.